Hello, everybody. My name is Tim, and we're going to talk about graspable math very soon in about 5 minutes. So I'm just testing out StreamYard earlier. So we'll start in about 4 to 5 minutes or so. So if you want to throw in the chat, if you're watching on YouTube or Facebook, where you're from, where you teach, what you teach, that would rock. So I'm really excited to share graspable math with you here today. So if you want to go ahead and say hello in the comments there, will be great to hear. I want to make sure you can hear me okay too. I have it on silent here so I can see comments coming in too as well from on another device. But hey, Rolando, how are you? Can you everybody hear me okay? Yes, we're good. Awesome. Cool. So again, we'll start at the top of the hour, 1 o'clock Eastern time, 10 a.m. Pacific. It'll be a 50-minute webinar. And then we'll do a part 2 at 3:30 Eastern, 12:30 Pacific later today. Hello. Hello. Hey, Shelby Hussein from Lebanon. Hi, Ronaldo. Glad to hear it's clear. Thank you. Hi, Sunita. How are you? Cool. So, yeah, let me add this here. That's where everything will be. But I'll go ahead and put that in as well. No, that's not it. Let me just get it for you. tinyurl.com/GM virtual math. Here we go. So that's going to be where the links and everything is, at least for today. Okay. So cool. Hi, Lisa. Teaching algebra. Awesome. If you're teaching algebra, graspable math is a must need tool in your tool in your toolbox. Has to be in the math teacher's toolbox, and it's an easy app to use. It's awesome. It's very easy. I know with this this is a crazy year for teaching. Everybody's stressed out. We're all burnt. It's hard to believe that June 11th was a month ago. We blinked. It's like it really happened. But yeah, graspable math is very easy to learn. It's very easy to use as well. So we will start very soon. Vincent, how are you? From France. What is it? 7 o'clock over there or something at night? I mean, I've seen you up at 2 in the morning sometimes, so putting stuff up there. That's awesome. Great to see and hear from you again. That's cool. Yeah. So let's see here. Let's go show the comments here, because once I start screen sharing, I won't be able to see many of the comments. So Daniela from Italy, how are you? Welcome. Glad to have you. From Ontario, welcome. Cool. Yeah, so we'll start in about 2 minutes or so. Going to respect everybody's time. So, yeah. I see a lot of you in the Google Slides thing. So this is going to be awesome. This is going to be fun. We're going to have lots of fun here. Lots of fun. So I love graspable math. I really do. I love Geogebra. I love Desmos. I love Mathagon. I love anything math ed tech that helps students actively engage them. Hello from Vietnam. Wow, what time is it over there? Welcome. Assuming, is it in the middle of the night there? Can't tell. You 12 or 13 hours ahead? But man, I'm so happy you're here. Thanks for staying up. That's cool. Portugal. We have the whole globe here. This is great. Okay, we got a minute to go. If you're just joining us live, welcome. If you're joining us on YouTube or Facebook, wherever you are, grateful for StreamYard here. So, good morning, David, Daniela. Actually, Daniela, to answer your question, the video already is on YouTube. If you're watching this live on YouTube and you take that red circle and drag it behind because you missed something, you'll go back in the past a little bit, but you can always drag it back up to catch right where we are. So, yeah, the URL you're watching on YouTube will always stay there. Okay. It's midnight in Vietnam. Ultron, thank you so much for staying up. Wow. That is awesome. So it is 1 o'clock, ladies and gentlemen. Welcome to this graspable math session here. In the next 50 minutes, we're going to explore Graspable Math's Canvas. Okay, and I want to first of all a shout out and say thank you to Howie Hua for organizing this hashtag Virtual Math 21 conference, absolutely free. Okay, and I'm honored to be a part of it. I also want to shout out and thank my friend and colleague Alice Keeler for also streaming this to her Twitter via Periscope. But wherever you're watching on YouTube, Facebook, welcome. And we're going to dig in right here and right now. And Daniela, we're going to literally do just this right now. So I'm glad you mentioned it there. So here's what we're going to do. I'm going to throw this in the chat again. Just we have right here. You see that when I'm screen sharing there? I'm going to ask you to go there. I'll type it in one more time for your convenience. tinyurl.com/GM virtual math. And that will bring us right to where we're going to go right here and right now. So I'm going to screen share just one more time here. Let me remove that. Okay, stop screen sharing there. Let's add this entire screen and let's rock and roll. So my ability to access the comments is going to be greatly limited, but I'll do my best to watch from my iPad over here as it coming in. So if you have questions, please feel free to put them in the chats. I'll do my best to answer all of them. I can't promise I'll be able to answer all of them in the 50 minutes that we have, but I'll do the best we can and have resources for you here. So go on the slide 2 here. This is kind of like the breakdown for today, at least. For the next 50 minutes, we're going to look at part 1. We're going to explore Graspable Math's Canvas page. All right. And in part 2, which will be 12:30 p.m. Eastern, I'm sorry, 12:30 Pacific, 3:30 Eastern, we're going to explore Graspable Math activities later this afternoon in a separate session, and we'll explore how we can formatively assess all student progress in real time. All right. Graspable Math is very powerful. So we're going to stick to only slides 3 to 6 right here and right now. So there's the address, ladies and gentlemen, graspablemath.com. It's right here. So let's go there. I will drop the link in the chat for your convenience as well. Okay. Here it is. Boom. All right. So what we're going to do is we go here. We're going to hit the green button that says Explore Algebra. Okay. We're going to explore algebra here. All right. And let me actually take myself out of I hear people saying no sound. Is that true? I apologize. I apologize. Let me try this again. I'm so sorry. Let's try this again. Maybe I just need to keep myself. I know what I did. I'm sorry. I see it. I apologize. All right. Let's do a sound check now. Does it still work? Now okay, I apologize. I totally messed up for the last 3 minutes. I'm sorry. I will not do that again. I have to keep my little thumbnail on the side there. I didn't realize I took myself out. I'm sorry. Brain fart. So anyway, let's go back. Let's go back. I'm sorry. So with the order of operations here, I think you could see silently what I was doing here, but notice that Graspable Math, it basically shakes its head no whenever you do something that's mathematically incorrect. Whenever I violate the order of operations, it doesn't like me. But now look at this. Imagine having your middle school, your upper level elementary school students, or your middle school students playing with this, maybe this very construction. Now, then I just asked my students a question. What did you notice? When I tried to evaluate expressions containing only addition and multiplication, what do you notice, right? And well, we kind of noticed, I would hope that not all students, but most students would discover that it looks like multiplying comes first, addition comes second. You see, here is an example of graspable math used for discovery learning. Student-centered learning. The students are at the center of attention, not the teacher, right? But they're just playing around with arithmetic expressions and they're generalizing, gosh, what did I notice? Well, multiplication comes first. All right. Yes. In terms of showing, we'll deal with equations in a second there, Regina. Absolutely. So we have a lot of demos here, but that's just a start. But I'm actually going to go to a blank canvas here when I went to explore algebra before. But I want to show you something powerful here. Let's actually insert I'm going to insert a Geogebra geometry app here. I'm choosing not to put the graphing calculator because it has limited functionality, but the geometry app has all the power there. All right. And here's a little tip. If you hit the arrange button, that's what lets you drag stuff around left and right and make it bigger, smaller, because I want some room to do what I got to do here. Okay. Transform. Use the arrange button to move objects around the graspable screen. And then we're going to go to transform to actually play in the app itself. So right here, this is like I'm on Geogebra's website pretty much. I can go here. I'm going to show the grid and I'm going to show my axes here. Turn them on. So check this out. If I go to insert, let's insert an equation. Algebra 2 teachers. Let's talk the equation of a circle. It could be the equation of a line, algebra 1. I don't care what it is. Let's type in some math expression. Okay, right down here. Let's type in x minus 2 quantity squared plus, let's see, y minus 3 quantity squared equals, say, 2 squared. Okay, so, and at that point, I'll hit done. All right. Again, I can hit arrange. If you want to move that equation, just make sure you hit arrange. You can move it wherever you want, right? But then you always got to go back to transform. Transform tool is powerful because watch this. If you look next to each equation or expression you write, you'll always see a white dot, all right? I'm going to click on that white dot, and I'm going to drag it slowly over to the graph and watch what happens. Boom. Well, it makes a circle. We surprised, right? But now it gets even better because right here in the Geogebra app, right, I can go to the algebra view and I could ask it, I can use the power of Geogebra in Graspable Math. Hey, Geogebra, what's the center of what you're calling EQ1? That's the 0.23, right? And I can go ahead and right here, I'm going to turn it on, right? And let me make the font a little bit bigger so we can see it better. Okay, but now, so we have the circle here, but I want to show you another powerful tool here that I love having students play with. And that is the scrub tool. To answer your question, Kelly, how did I get the equation to show up on the right? All I did, I could do it to, let me just go back. I go to transform, okay, to enter an equation, go to transform, go to insert, and select math expression. When you do that, you can type your equation right here. Okay. Another shortcut is to just take your finger and press and hold down on your mouse, a trackpad, and you'll see a circle. You could do a graph, an equation, or text. That's a little shortcut right there. But again, insert, for those of you on an iPad, can't do that. You can just go to insert and then expression right there. Okay. But check out, I want to show you something here, the scrub tool. I love having students scrub because scrub is dynamic and it lets students help students make conceptual discoveries of what's truly going on here between the algebraic representation and, in this case, the geometric one. So watch this. I press scrub. Look at this. Now, if I scrub, now if you look at this equation here, see how I have an up arrow and down arrow here, and up and down arrow. So I'm going to go ahead and carefully scrub that too. I'm going to press on my mouse and drag it up. Oh my gosh, look at that. Now, scrubbing in Graspable Math is the equivalent of Desmos and Geogebra slider, if you will. Okay, so I could slider, and you know what? I don't like that scrubbing by 0.1. So if I go to settings, I can make it any way I want. If you go to settings and go to scrubbing, it's somewhere down here. Scrubbing numbers. Just make it 0, the 0th place, which is the nearest whole number. And just be sure to save your changes down there. Okay. But then now, when I scrub that too, again, see how it's going by integers, right? And right here, it's going by integers right here again. And I can scrub the big 2, which we know is the radius there. But again, I can build on this. I can play with this. But again, I want students to discover what? That when I add or subtract from this input here, it's going to move, or I should say, yeah, or in the case of a function, I know this is not the graph of a function, but when I add and subtract from an input, it moves the graph left and right. And when I add and subtract from an output, again, I know it's not a function, it moves up and down. And I guess this parameter controls the radius. So this lets students see and explore for themselves and have them tell you. Okay, that's what I love. That's what I love about it, about Graspable Math. It's powerful. And again, we're just beginning to barely scratch the surface there. I have a version of this that's done already. It's on a couple slides, so I'm not going to save the changes here. But let me show you what else it can do. Let's talk about simplifying and evaluating expressions. We're on slide 5 there. All right. Just get out of here. But look at this. Again, it's fluid. When I click on an operation, gosh, it doesn't like me. Why? It doesn't like me doing this either. Again, I try to actually have students tell me why. Why is it shaking its head? Oh, wait, they're not like terms. You can't combine them, right? Again, there's lots of students that want to call this put 4xy here, right? But let's see what's got to happen here. Now, granted, I can move stuff around. See, I can move that beyond, or I can go whatever. But what I really need to do is multiply first, and we have to recall distributing. If you want to distribute here, just drag the 2. In this case, we'll drag the 2 inside. See, it's fluid. I love it. Here we can drag the 5 inside. I can bring it to the left side. I can bring it to the right side. See what I mean? Watch when I go to the right. Or actually completed it already. But now that negative sign, why not? If you want to distribute a negative, you got to double click. Tap, tap. Double click. Or that's one way to do it. Right? But see, here's the part. Here's why I love this app so much. In order for students to actually complete this simplification successfully, they have to know what to do. I mean, sure, they can use PhotoMath, take a picture, and it does it for them step by step. And I'm not knocking PhotoMath. I love PhotoMath. It has its place in the classroom. But at the same time, it's like an app like this helps students, it reinforces procedural fluency that, you know what? I need to add the X terms together and the Y terms together, right? So there's a couple ways I could do this. I could take the 2x, see? If I want to move this 2x next to that 2x, I need to actually drag it and drag it far down. Let me actually zoom out a little bit here so it's easier to see. If I drag that 2x down far, you got to just keep dragging it down. It'll bring it lower enough so otherwise it just takes the coefficient 2, but you want to drag the whole term 2x. And I'm going to put it right next door to the 15x because I know at this point, look at that. I know that if I click that plus, it'll actually like me because those are like terms. Now I'm going to take this plus sign and I can just move this next door here. And now I can do this. See what I mean? Again, students, oh, I guess that's a possible operation, right? You see, students still have to know what to do. Graspable math is not going to allow them to the arithmetic mistakes, but again, we're reinforcing procedural fluency through the conceptual lens, multiplying before adding, right? The big arithmetic principles are still at play here that we get kids to think about. Okay, if that makes sense. So let's see, comments refreshed here. All right, so let's actually take a look at and actually one little thing you could do is actually if you drag the minus sign, it takes the term after it. If you drag the coefficient, you just got to drag down far enough to get everything like here, like that. And then if I drop that right over it, see how it's a blue square? It'll actually combine it like that. And I can bring this down as much as I want. Okay. So there's the case of simplifying expression. But let's actually evaluate really quickly. I'm not seeing any more comments here unless YouTube's not refreshing. I'm sorry if it, let me see here. Okay. So let's actually take a peek at this one here. So -3. Again, if I just take that -3 there, see, I could just substitute it right in there. Sure, I believe students should be able to do something like this on paper, absolutely. But again, every time they do it, one or two of these, hey, go to Graspable, check your work, see how you did. Have the students learn from their mistakes. They don't need you to tell them. They just simply need you to say, hey, go to an app like this, type it in, and let's input -3. Which you can do, right? Oh yeah, I got to subtract last. That's right, but I can multiply, right? And actually remind you there. Minus subtracting a negative is the same as adding a positive, right? Yep. Okay. And then lo and behold, there you go. I believe the more as a teacher that I make my students actually check their work, they become. They're formatively assessing. The more formative assessment I have them do, in my opinion, I think the more powerful, the less chance they're going to actually mess up later on. All right. So there's a case like this. Let's actually talk about solving some equations here. Let me go back to Graspable here. Related to equation. I don't have any articles at the moment. No, I'm sorry. The YouTube comments aren't refreshing here, but let me remove this for a second. But we'll go right back. I just want to make sure I address some comments here. Questions. Again, my humblest apologies for the sound before. I really apologize for that. But let me see. Magic. It's just amazing. I don't know. Yeah, that's a great point, Susan. Hiding intermediate steps is a great discussion about what you may not need to show, right? That's very valid point as well. All right. So let's to answer that question, if you go to settings in the upper profile, you have all these options to actually have Graspable do, not to do. Some teachers want parentheses to show when substituting. It shows by default, but you can turn that preference off if you want. Again, if you go to the settings in the right corner, you'll see a lot of what you can turn on and off there. So definitely, I would definitely explore that. Okay, for sure. All right, I think I got everything here. Awesome. Okay, so why don't we keep rocking and rolling here, shall we? And let's go back. Let's do some equations and inequalities. This is the fourth one here. All right. You could do. I don't have any literal equations like those with two variables, but again, when a student solves an equation like this, sure, I start with one step, undoing. What's the opposite of addition? Subtraction. We build up to something complex like this. I'm never going to give a student something like this on day one, But right here, I can't add. Now, some teachers can be pretty picky about the order in which students solve an equation. Graspable math is not. If a student wants to take this x term and move it to the other side, you can, right? What just happened there? Let me undo. Again, undo there. Like, what did you just do there? Oh, why did it subtract? Well, I can actually think, well, gosh, if I'm really doing the same thing to both sides, right? I can doodle in there, doodle in there. You see what I'm saying? And now I can go back to transform. Oh, that makes sense now. All right. See, that's what you're doing. Like the balance, what you do to one side, we're doing to the other, right? And yes, now I got to distribute that negative in there, right? There we go. And now it just becomes the juggling act. I know teachers, yes, listen, I know you want them to get the X's first and the numbers last, but you know what? Let them do their thing, you know, it's okay. As long as you're doing that, you know, but show me what you're doing. You can have them draw the steps in. Graspable math, but you know what? If you want to, you can have them literally show what we're doing to both sides, right? Well, that's the seesaw, the balance there, right? Well, you added 8 to both sides. You added 8 to both sides. See what I'm saying? There you go. We'll go back to transform. And then, yeah. So now we can move that. Now, some students will do this. You might be surprised that some students may do this and get something they don't want. And it's like, oh my gosh. Then they start juggling stuff around and it's like, oh, I can't do this anymore. Listen, again, that's why that undo button is there. Have them undo as many steps as they need. When did it start looking really weird, right? We don't want any rational equations here, right? You know, we're in algebra 1 for crying out loud. So let's just undo, right? And again, it's just a matter of getting used to it. Again, if you want to take that term, you just got to do one of two things. You drag the sign in front of it, or if you choose to drag the 7 or the X, see how I'm just dragging the 7? Just drag it really far down. It'll bring it with it there. Then you can move it all the way to the other side, right? And then, lo and behold, what undoes multiplying, guys? Oh, dividing, right? Okay, and then if you double click on that, you can actually get the decimal equivalent or an approximate. And in the settings, you could choose the decimal accuracy, the point, you know, how many spaces you want. All right, yeah. So there's a case right there. Now I want to show you. Now we'll just barely touch on inequalities for a second right here. So, but I'm going to insert the graphing calculator from Geogebra. Watch this. Ready? So here's what we're going to do. Oh, remember, I got to hit arrange to make it bigger. Arrange, let's see how everything here is in its own bubble there, right? Kind of like messing it up a little bit, but I think it's right there. Yeah. But I'm going to arrange and make this slightly bigger. Let's see. Okay. Now, whenever I had my kids, you know, as a teacher, I was never one to teach my students the rules. I wanted them to kind of notice patterns and discover for themselves, right? So sure, we have to divide both sides by 5, right? And we'll bring the 5 up into the 10. It becomes 2, right? Let me just drag this down. But now, watch this. This is really interesting. I would have them do this. So you know what? Let's arrange. Let's bring that down a little bit further. Go back to transform. Again, arrange lets me juggle. Transform lets me move stuff around, right? What would happen if I threw that inequality right in here? Let's just drag it right in there. Ooh, let's actually zoom out a little bit. And I'm going to start scrubbing now. But first I want to go to settings and change the scrub place to 0 if it's not. Oh, it is already. I think I had that saved already. Good. But watch this. If I hit scrub now, again, it's all about that leading coefficient, right? So this is the coefficient I'm going to choose to scrub right here. Watch this. If I scrub, I asked my students, I could scrub it up. Oh gosh, what do you notice as that coefficient gets higher? Well, the solution set gets bigger. Actually, that's kind of a bad statement because isn't the solution set infinitely big anyway? But the boundary line moves closer to 0, right? And then I'll say, well, what happens if I make it lower? 10, 9, 8, 7, right? 4, 3, 2, 1, 0. Oh my gosh, what just happened? Right? See here? All of a sudden, it reflected. It like literally, see how it actually knew to flip the sign. Like Graspable is flexible. It knows what it's doing. But again, I like to give students a bunch of inequalities. Some that have negative signs in front of the coefficient, some that don't, and have them generalize. What did you notice? And then we talk about the why later. All right. But apps like this help students discover. Here we look at it graphically, and we looked at it algebraically simultaneously. Okay. In that particular case there. So let's see, any more things here? I don't see it. So, all right. But let's actually solve a system now. All right. Let's actually solve a 2x2 system, dimes and quarters, right? I apologize for those of you that don't live in America. I could have used different currencies. I realize, but here we go. You ready for this? We have dimes and quarters in a piggy bank. There's 300. This is the typical systems question, right? Teachers, we love giving our students. Can you set it up? Can you solve it, right? And again, whether it's mixing liquid mixtures or whether it's, you know, dimes and quarters or, hey, money in account A, money in account B, 10% acidic solution, whatever. Structurally and analogously, they're all the same problem, right? And we should treat them structurally the same way too. So dimes and quarters in a piggy bank, 362 coins overall. The total worth is $71.90. So let's do this. Let's actually solve it both graphically and algebraically right here on this canvas. Because teachers, like a lot of teachers, when I've seen teachers teach us in the past, and even my first few years of teaching, when I taught systems, it was like we spent a day on graphing because it was really just graph the line again, but we did that in the last unit, and then get to there, and then we just, okay, but we're all in such a rush to get to the algebraic, right? But I really think I think that as a whole, we often underemphasize the power of the graphing approach. So that's why I'm going to throw that in here as well. All right, so let's throw in the graphing calculator here. Actually, let me do this. Try to make it bigger. I'm gonna hit I should have did that before. I'm sorry. Let me hit a range. I'll try to make it a little bigger. Now, normally, when I'm working purely algebraically with students, I like to just do D and Q for dimes and quarters, but I'll just I'll do some text here. I'll insert some text to show my work or my thought process. Now let's let X, because if I want to graph on here, I got to use X and Y. So let's let X be the number of dimes, and Y is the number of quarters. Okay, there we go. Just for my own sanity, because I'm going to forget. All right. So then I'll ask the kids, well, let's actually translate this into algebra. Again, I don't like to get to solving right away. I just want them to translate first. Just write the systems first. We'll deal with solving them later, right? So let's write it. So again, if I insert an expression, let's see. Well, there's 362 coins overall, so I guess that's the dimes plus the quarters is what? 362, right? Let's hit done or enter. We'll arrange, move that equation up there. I can make that smaller, actually. See the bigger, smaller right here? Can make this works for equations and expressions. So I go right there. And then now, let me go back to transform. We'll go to insert. We'll insert another math expression there. And let's see. Each dime is worth what? Oh, 10 cents. So each dime, oh, I got to use X here. X is dimes. So each dime is worth 10 cents. Each quarter is worth 25 cents. And the grand total was what? $71.90. So $71.90. Hitting done or enter accomplishes the same purpose. Just puts it right on the screen there for you. Okay, there we go. So now let me make these larger for a quick second so we can see them. So there's my system now. Okay, so now let's talk about what we talk about. I know we talk linear combinations, whatever, but honestly, if I could substitute, I'd rather substitute. And when I actually teach this, I hate using two variables. I just rather have students automatically think as one being X and the other as a big amount minus X. Again, we're all different. I'm not saying one's right or one's wrong, but the point is, obviously, we have to do something like this, just basically isolating a variable. We could talk about that. Well, literally, what just happened? Well, I subtracted X from both sides, right? So now, here's the thing. We could take this. Let me actually make this a little smaller. Zoom out a little bit. Move this here. Whoop, arrange. Again, sometimes the challenging part for me is arranging this canvas perfectly because I like overlap on things. But I think this will work. So here we go, right? So now, back to transform. I'm going to take this, and I'm actually going to take this equation. I'm going to drag it in here, and I probably should zoom out. I'm zooming out with my fingers, the mouse there. Okay, and so I'll take this other equation. I'm gonna put it in right over there, right? And yes, I know the intersection is what I'm looking for, but I'm not going to get there yet because I want to show you something here. All right. I want to show you this. If I actually take this, now, again, we know that we need to take the whole 362 minus X, and we have to have graspable maths substitute that in for Y right here. Here is how you do that. Now, if I click on this here, am I on transform, right? See, what I have to do is hold down the shift key. Press the shift key down and click on the 362 and click on while you're holding down shift. Again, if you forget what, again, that's very important. If you want to drag a whole expression full of more than one term, you have to press down Shift and then just start clicking anything you want. See how that's highlighted in blue? Now, if I let go, it's all highlighted in blue. Again, hold the Shift key down while you're selecting your terms, and it'll turn as many terms blue as you want. And now when I drag this, look at, you see how the, I don't know if you could see it on my screen, see how the Y is blue? It's like Graspable Math knows, oh, that Y here is the same as this Y right over here. So let's plop it in. And the rest kind of follows from here. Let me just make this a little bit smaller. Let's transform. Now I want you to see something here. I'm going to drag this equation out. I'm going to drag this equation on here. Can I see this? Notice how there's only one X here, right there. It's going right through the intersection there. I love to have students see multiple representations here. Now we can just go ahead and solve it. Oh, you know what? I almost screwed up there. I didn't even see the X right there, right? I guess I got to take this whole, drag this. Oh, can't drag that. But remember what I have to do? I have to drag it down far enough, drag it far to get the whole thing. Now I can put it over here and go ahead and take care of business, right? Right there. So then I can move this over and subtract and divide by -15/100. And we could either double click on the fraction or drag that denominator up into the numerator, and it looks like 124 dimes there, right? So let's see. If I go right here, I'm not sure you can see that. Oh, what does 124 represent? See, we're making the connections. Any time that I drag any equation in here, see how that vertical line is getting darker and darker? It's like it already knows, right? And sure, now I could take 124 and bring it in here and subtract it. Obviously, I don't need Graspable for that, but you see what I'm saying? So again, this is an awesome platform for solving equations and problems just like that. Again, you set it up. If you want the graphing piece, you have to use X and Y, but I could have used the letters D and Q here if I truly wanted to. Okay. But again, I love Graspable because when students work through this, when you have students do this on paper only, they make those arithmetic mistakes over and over again. They forget to distribute completely. They forget to distribute a negative. See, Graspable takes care of that while it helps you help your students focus on algebraic structure. And it emphasizes that, in my opinion. And then you can, when appropriate, talk about the details with the arithmetic, if that makes sense. Okay. So let me go back to StreamYard there because these comments aren't refreshing for me. I wish they were, but let's see here. Yeah, Vincent, I agree. Totally. So yeah, Julio, you could definitely do quadratics. I think I'll have time to show you one after for sure. Yeah, we can resolve that. Julio, I'll answer that question after this next demo here. All right. So let's actually do just that. So I'll add myself back to the stream and keep going here. Now let's actually talk about a 3x3 linear system geometrically. Say what? Yeah, that's all pre-made there. And again, all these links are on the slide on the slides there. All right, but I'm going to actually, when I have my students work with 3x3s, again, I've met some teachers that were adamant. Students have to solve it algebraically. And I think there are districts and state departments of ed that require them to do it algebraically. Again, my opinion only. I'm not sure why. But I think setting up, modeling the problem is very important, right? But again, when it comes to a 3x3, getting lost in the algebra can be very likely to happen, right? So let's actually bring Geogebra in here. This time I brought in the 3D calculator. Okay, and I'm going to go ahead and hit transform. Let's make the font size bigger. Settings. Just make it really big there so we can see what's going on here. So you ready for this? There's my three equations there. And we'll go to that circle. We'll drag it in. Boom. Whoa, what is that? The kids look at that, huh? It looks like, and they start talking to each other, like Algebra 2 student. That's a plane, isn't it? Yeah. I mean, 3 variables, 3 dimensions, right? That is a plane, right? And even here, we could drag the second one in. 1, 2, and let's drag in the third while we're at it. 3. Now, doing this by hand, geometrically, that's going to be a pain in the butt, next to impossible for most. But Geogebra and Graspable Math together make it not so bad. All right, and you see how it populated? It put the equations right here in the app. So I'm going to turn off just two of them, just one of them, I'm sorry. And in Geogebra, now you might not have used Geogebra before, but I'm going to show you a couple things you could do here in Graspable Math within this Geogebra, say, app. All right, go to the tools. Don't you want to see where those two planes intersect? Let's intersect them. Intersect two surfaces. Let's see. Select one, select the other. And then we can recall that concept from geometry. Oh yeah, if two planes cross, they always cross. I mean, planes are either parallel or they cross in a line, right? There's no other options. Lines could be skew, but planes cannot be, right? So right here, we go back to the algebra view there, right? Let me just put on plane 1 and 3. And now we can find the intersection of those two planes. This is cool. I love this. So we'll go back to the tools. Again, under tools, you want to intersect two surfaces there. It's in the first submenu there. Select one plane, select the other. And look at that. Now go back to algebra. I'm going to turn all the planes off. Just like in Desmos, you just turn the bubbles on and off. Same thing here. I talk to students. What do you think is important there? I try to have the students build it themselves. Many times I don't need to tell students what to do. And I'm not talking for my honors class either. Even for students in I'm not a big fan of tracking, but districts I've worked for have done it. But the thing is, students, you work together, they can work collectively and figure this out for themselves if you give them the chance. Many of them can. But let's go to tools and let's just select the point tool. I mean, those lines cross at a point, right? And if I just click right on there, look at that. Let me hit the move arrow to select it, and I'm going to go to A. Let me show the value. 3, looks like that's the solution right there, right? And it also appears right there. I forgot to show you this last time, but did you know that you can also, many people don't realize this, you can actually drag an element if you could drag an element, if you press down on the mouse pad and just hold it with your thumb and drag to the right, you can actually drag that element out into the graspable canvas. I'll undo that and do it again. Again, see how I have in the Geogebra 3D calculator? I'm gonna select right in here. Make that button gray, or that area gray. If you press and hold down with your finger and keep pressing that mouse down, you got to keep pressing and drag it all the way over. You can get over there. Now let's have a little bit of fun. Let's work with this algebraically and geometrically. Let's go back to equation 1. Let's turn the planes on again, right? Did we forget about our friend the scrub feature? Well, how would this picture change if we decided to scrub these coefficients? I mean, sure, could I build this in Desmos or Geogebra and make sliders A, B, C, D, E, no, can't use E, D, F, right? And I can move sliders, but man, how convenient would it be just to be able to, say, scrub the 3 here for a second and see how that solution changes. Look at that. Now, granted, I made it nice, quote unquote nice, so a nice solution. But you can actually do something like, what does changing that do? See how this moves how does that move the plane? I firmly believe that since we live in a 3D world, we should be incorporating as teachers more 3D representations of algebraic expressions within the curriculum. Right? And I've said this before too, even with Geogebra 3D calculator, you can graph the function y equals x from 0 to 4, spin it about the x-axis and make a cone. In Geogebra, it takes 3 steps. So we could have kids build 3D surfaces just by using Algebra 1 concepts to build the cross-section. And I can make some algebraic and geometric connections here within the Graspable Math Canvas. Maybe we'll do a webinar on that some other time. But I know we have about 10 minutes left or so. Oh, yes, Sanjita, very powerful indeed. I wholeheartedly agree with you. I totally agree with you. And so, like I said, the possibilities that you could work with here are absolutely endless. I want to answer my friend's question from, I forgot who it was. Someone asked about a quadratic. I can demo a quadratic for sure here. I will do that now. We exhausted all these quick examples, pre-made things to save time. But on slide 6, I want to go back to that equation of a circle that I showed you before. of that presentation. And literally, this is a version that's done already. All right, and if I hit the scrub tool right here, this is the circle that we build way in the beginning. But see here, you can actually build on that. I built this in Graspable Math and then I built in Geogebra after. Notice when I hit scrub, see how scrub is highlighted there? I like to ask my students, how come I don't see little carrots pointing up and down for the 1, 1 here, right? Like, why is it not let me do that? And it's like, oh, well, they have to think about it. That's the center. Like, these are the independent parameters. I could choose to do those, right? But the others, I really cannot. I'm not sure how that got to 2, but there we go, right? But there you go. Okay. So, yeah. So let's do a quadratic here. GraspableMath.com. Steve. For algebra. All right. Let's see here. So I don't know. Let me throw in a. Now, you notice over here, I just want to show you this. I don't use this too often. Some teachers use it more than I do. There are formulas here. So if I see something that looks like this, it'll recognize it and automatically fill the quadratic for me on a day where I want to maybe emphasize only order of operations. Let me show you what I mean. Insert expression. Let's do, say, 2x squared minus 5x minus 3 equals, I don't know, 0. Okay, so there it is. Now look at this. If I go over, let me make this bigger. If I go over to where it says formulas, right here, see if I click on this, you see quadratic formula there. It actually the Canvas recognizes, hey buddy, you got an equation that looks like this. So what I could do is drag it right over here to apply it, and it'll fill it in for me, if you will. Now, sometimes I don't like to show students that, but like I like to actually have students. I like to literally have students actually write the expression themselves, like x equals, like how would you actually write that? The opposite of b over 2a, plus this plus or minus. There is a plus or minus here. I just got to find it. I think it's under here. Come on. I should know this. I'm sorry. I know it's here. And anyway, but we'll just do one for now. I'll answer that question after. But plus the square, and then I get the fraction bar, then get the square root. You see what I'm saying? I like to have my kids actually fill this in, and then at this point, let me just actually do this. I'll leave it at that. Let's say I want my kids to get the vertex only. I can actually take this. Oh, I see. It's being displayed as an image. That's why. But basically here, if I were to just type in the number 3, and just I could drag that right in here and fill it in. Say, I know I should have been -5, but you know what I'm saying. But yeah, but I can evaluate this to my heart's content. Okay. One thing that I forgot to show right here was a open middle problem. I want to show you how even for upper elementary here, open middle multiplication problem. I think I skipped this one. It was number 2 on slide 5. I think this one was from Howie Hewitt and Robert Kaplinski, is one of the two, but this is on Open Middle's website here. But look at this. I love this problem for upper elementary students. Using the digits 5, 6, 7, and 8 exactly once, and picking one of the expressions below, create the greatest possible product out of the two, right? So this is a great discussion for students. Well, is it 987 times 5, or I'm sorry, is it 876 times 5? Or should it be 865 times 7? You know what I mean? Or 8765. There's a lot of possibilities here, but I'm thinking to myself, what if we went to Graspable quickly and literally express that? Isn't it really what? Having kids make sense of arithmetic structure, right? 100 times, say, 8 plus 10 times 7 plus 6, all now times 5. Isn't that really 876 times 5? Right? That's one way of thinking about it, right? But now the other way, what would it look like? How would I set up it looking like this? A 2-digit number times a 2-digit number. Because see what I'm going to do? I'm going to scrub at the very end and try to analyze all the possible products. All right? So I go back to insert expression. Well, let's see. I ask students, well, how do you write that? How do you write a 2-digit number? Well, it's 10 times, I think one of them should be, the 10s digit should be 8 for one of them, right? I'm like, maybe. Yeah, let's try it out. 8 times 7 times, let's say 10 times 6, maybe plus 5, right? We'll arrange that. And now we can quickly just go ahead and transform using the order of operations right here. But see, remember, we can keep in step with what's going on, right? And figure out, I know I'm running out of time, so we'll finish it up here, take a question or two. But look at that. So what is the biggest possible product? See how my original intuition of 876 times 5 leads to 4,380? But what if I were to scrub now and actually, I scrub by ones there. Oh, gosh, that's kind of bad, isn't it? But you see here I can actually, 87 times 65. But what if I made this a 70? I forgot what the answer was. I think it might be 76 times 85. I can't remember. But the point is, I think that was it. But you can actually have students analyze, explore, area model, of course, but here we could do it purely from an arithmetic standpoint. So that's the Graspable Math Canvas in a nutshell right there. I know we have about 3 minutes left or so. But basically, if you have questions, feel free to throw it in the chat there. Definitely happy to answer it. But that was part 1. Part 2, we're going to start up at 3:30 Eastern time, 12:30 Pacific. We're going to explore Graspable Math's activities page. And with activities, I can give you engaging tasks to work on, and I could formatively assess you in real time. All of you students will join my one session, and we'll see what you do for the first 5 minutes or 10 minutes, and then I'm going to show you how you can build your own activities and make sessions out of those. Okay. So, any questions here? Simple students benefit Graspable. Well, that's a great question, Sanjita. I could try to address that in a minute or so. How do they benefit with it? I think to use it as a scaffolded structural support in the beginning. Like, some students don't need it, but I think it's very powerful to help students support procedural fluency while maintaining the concepts they previously learned, like like order of operations. At least it depends on, the students, of course, but like many students forget, adding comes after multiplying. So with Graspable Math, that continual reminder is always there. I'm one person, and with 25 students in my room, I can't be there to always remind students not to do that. But Graspable can do that for me. Seems like kind of like the big questions. You know what I mean? Graspable Math is amazing. Yeah, my head hurt amazing. My head hurt a lot too when I first wrapped my head around it. But the more you play with it, the easier it comes. Eleanor, is it free? As far as I know, yes. I know they. If you go to the activities page, Graspable Canvas is free. If you go to the activities page, which we'll look at next time, they let teachers create a free account and you can build your own activities. So from the teacher standpoint, it's absolutely free. We could talk more about that next session. It is. But yeah, so it's thank you so much for watching. If you're looking for more ideas for students that are learning, feel free to, if you go to the slides there, and that if you take a picture of that QR code right there, I have some links to some ideas using lots of apps. If you want to hold your camera up there, I'll leave it up there. But thank you so much for joining me today. I had a lot of fun. I hope you did too. And I hope you can make it back here for 3:30. Different YouTube URL, but if you're on my YouTube channel or Facebook page, you'll definitely be able to access the link there. So thanks so much for joining me. Thank you, Howie, Alice, for helping, Alice for promoting it, and Howie for organizing all this at Virtual Math 21. Hope you have a great rest of your day, and hope to see you back here in a little bit.